Yo yo yo, good morning, another day, another stream. I'm not gonna start today's stream with too much talk. We're gonna jump into it real quick because what we're gonna do, I wanna get done this week. So as I said to Derek over on YouTube, what's on schedule today is some boring extension slash rework of some underlying terrain systems to pave the way for water, snow, mud interactions, edge foam, and some other very interesting stuff. And let's see if we can open the issue rework terrain data. So this is probably going to be, we're probably going to do this in in a very fragmental way. So today we're gonna rework terrain data, change how data is represented, and we might as well also do this. And when we have those two in place, so the idea is to rework terrain data, just the underlying structure, not the methods or entry and exit points from the class. So hopefully everything will work as it did. It's just that the underlying data is held in a little bit of a better way, a more optimized and easier to work with. And when we have that in place, we can start with some extensions. And I want to pack additional data into textures. So first of all, I want to remove some data we send to the GPU because we don't need to. And then I want to send some other data instead. Data that will hopefully make interaction displacements and water shaders a little bit easier to do. One of the things we want to get in place is edge foam, and since we don't want to do it by view space data or camera data, so what we see, we're gonna have to create it from in some other way. One way is to add a secondary camera, place it on top watching down, and collect and store data that way. I want to avoid that, and we already have a system that supports a lot of data for each terrain patch, so why not rely on that one instead? What I'm a little bit scared of though is for each frame we're pretty much going to have to update this texture, and we're probably going to do it by I want to try here, so this is very experimental, but every entity in our game, so every pretty much everything in a scene has an entity apart from the terrain. So we have static entities like stones and stuff like that. They are gonna have to write their position data down to the texture, and if every entity does that, and then if we're close, the camera is close to that terrain patch, we update its activity texture, and that activity texture we're then gonna use to create cool stuff like this and this. So yeah, that's what's planned for today. Terrain data currently store it as native array color 32 data pointers. I said yesterday that this was because the conversion to textures would be easier, but this one also led to some pretty weird shit we had to do. Mainly if we wanted to change one of the data, so alter terrain data type with value, old values and stuff like that, we had to do it like this. We have to create new structs, and on it goes. We're gonna keep these for now, hopefully reduce this a bit, because we're gonna go a much simpler way when it comes to terrain data. So I'm thinking of doing Let's see here. We also want to make sure that terrain data should be thread safe, because we're going to have a lot of different threads altering and getting data from terrain data. So for instance, our AI agent will always fetch, and I'm thinking of doing all the AI calculations on a separate thread. Yo, what's up, Calvino? God morgon, god morgon. So instead of doing this, we're gonna take a quick look at texture 2D. It's very important that we use, I always forget which one is the best one here. Color, I want to avoid using color. Would rather rely on something like this. Source data start index, this might be what I'm looking for. Sets the raw data on the time map direction, CPU, memory. The data layout must match the texture format. This one sucks a bit. If we knew exactly how we wanted to divide or separate our textures, we could rely on this and create very nice custom structs here. What I would like to see though is, it depends on how the data is stored in texture 2D. I'm assuming that it's stored in, so if we have an RGB A32, it's stored in memory as R value, G value, B value, alpha value, then the next pixel. And that is gonna be, yeah, we might have to define. This one is color as well, so I don't care about that. This is color. Set pixel 32, this is also color. So set pixel data, is that actually the one? Get native texture pointer. Int pointer. We're gonna skip that one as well. Okay. Yeah, okay. Why not? But then again, I want to avoid structs, because if we're going to set one value, and if we use structs here, we're pretty much back at the original problem of when changing one value, we have to change many values. Unity texture 2D. Yeah, fuck, that's not good. Use a structured buffer bool array to send the data. Okay, so this is probably something we want to do in the end. The thing is, I want this, like this is data I want both on the CPU and on the GPU. Best case scenario for every frame, in every frame. Okay. Harry O, what's up? Do you need MIP maps for your terrain data? I don't think I do. No. Let's put it this way. It could help with some minor things. So in a best case scenario, I could use them, but I will definitely be able to continue if we cut them. Okay, this is very good. I'm gonna have to do a lot of research today. I can rephrase my problem to something like this. Let's say that we want an activity texture, so that's pretty much, I don't know if that's the correct term, but we want objects to affect foliage, for instance, so we need to keep track of where they are, how long they've been there, and the movement, pretty much. One solution to that is to add an extra camera from above, looking down, and just render in each frame. And then we get like a activity texture, and we can use that one. I want to do this, but I don't want to do it with the extra camera. Instead, I want to do it in the terrain data, basically. And if we skip the extra camera, I think we can do it more optimized. I just need to figure out exactly how to work this, avoid the whole texture stuff, right? What's up, Geralt? Harry, it will make things harder if you need them, so probably leave it to later. Yes, I think that's how we're gonna move forward here. It's basically this. Fuck, I'm always trying to rephrase this problem to make it as easy and understandable as possible. I want to, for each frame, I want to have access to data that says where an object is and how long it has been there. I want it represented in a grid-like structure, and I want this information both on the CPU and on the GPU. Best case scenario, updated each frame. Worst case scenario, we can do it every other. I want it on the CPU because we're going to use it for our AI to calculate where and when it should go to stuff, and for interactions. I want it on a GPU to be able to affect world stuff like water, foliage, mud, whatever. Structured buffer. Harry, are you referring to terrain data, or is it that something else? You want individual objects represented by a texture? Yeah, I might be a little bit too broad when I talk about our terrain data in this game. The terrain data includes a lot of stuff. So it's not only terrain height, it's also foliage properties, water properties, and now I also want it to be object properties, basically. So let me do let me draw something real quick, and hopefully it will be a little bit clearer where I'm getting at. I'm not, and all of this is up for debate. I'm not completely sure exactly how I want this to be, but let's say that we have this terrain, we have a character here, we have water here, we might have some grass here. So basically this is, currently we have, this is represented by a texture, so a grid. We don't care about Y, so it's just XZ, where each texture, so for the ground we have a simple height map. So we have high values here, low values here in our texture. We also have another texture or another channel of data, which is the water. So for this part we don't have any values. For this part we have water, so we have the water amount. So maybe like this. Then we have grass here. So we have another texture with foliage information and stuff like that. So grass here we maybe just have, so this one has a value that is non-zero. And now I also want to have like an activity texture. So in this grid I would like to highlight the pixels that this object occupies, so it will be here, and the data I want it to be is like maybe minimum height, max height for that pixel, and for how long it has been there. And it's this texture I want to create. I won't say this drawing might not make things clearer, but I'm doing my best. And previously I've relied a lot on texture 2Ds, which is not that good of an approach. It works for height maps because it doesn't change that often. It works for water as well because it doesn't change that often. It works for foliage as well for the same reason, but it won't work for this because this one will change a lot. What's the use case for time spent in that position? For instance, if the object enters water, we want to create stronger and bigger ripples. If it just entered, and if it's more static, like we want to create smaller ripples, right? It doesn't have to be time per se. It can also be a direction vector where the amplitude or the length of it is how much it affects it. So if something is static, it has pretty much a length of 0. But it has to be something that is temporal related. We need to store some data that we can actually use in a time related fashion, if that makes sense. And then again, the previous example. So what I would look for here is a solution where this entity, if it has updated its position, it writes its position to this data, and if this terrain patch is close enough to the camera that we care about that data right now, we send this one to the GPU. It has been updated, so we update it on the GPU. Compare this to a solution where we would add a second camera right here, which renders every object that is of interest with a different shader and writes it to an output texture. So it's pretty much this use case I want to achieve, but I want to achieve it in a little bit of a different way. This would be so very easy, I think. But then again, if we do this solution, we're only having it on the GPU. So then we're going to have to send it on the CPU if we want to utilize that data on the CPU. Because this would be extremely straightforward, I think. So for shaders we care about, we add a second shader pass. We add a render feature that renders all of those objects from this position. And yeah, this comes with its own drawbacks though. We're gonna have a full pipeline of culling and stuff like that. I'm just wondering, does this approach make sense, or am I crazy? It could be easier to do the camera method and estimate the CPU side. Yeah, definitely. Also, what I'm a little bit afraid of with the camera approach is that I don't know how, like, this is not very important for my game, but I'm very fond of the idea of supporting mud and snow. Snow is a little bit more important. We're gonna have seasons, but if we have snow, for instance, you want to deform the snow based on object activity, right? If you go with the camera solution, you're always gonna have a panning texture of activity, which means that if we're located here right now and we deform the snow down here because our object stands here, if we then pan the camera away and then we can pan it back, and now we don't have this object standing here anymore, we will not deform the snow, which means that you don't get persistent visuals for stuff like that. You can do the same example with water, although water is more forgiving because it moves way quicker and resets. But you could pretty much have an object running in the water, you get ripples and stuff like that, and then you just turn the camera around for 1 second and right back, and then you will have an entirely clear plane of water again, right? This solution wouldn't have the same problem. This would be way more persistent. That's true, but how would you maintain it unless you intend to keep the whole map as a texture? We pretty much is gonna keep the whole map as a texture. Right now, for testing purposes, we just have one big patch, but our terrain can be split into multiple patches, which is what we're eventually gonna do again. This was just for water testing. So let's say that each patch is 128 times 128 vertices. That means that each patch is gonna have a set of 128 times 128 textures attached to it with height data, foliage data, and so on. And that's pretty crazy, but the good thing is that if we have a patch solution, we can we only care about updating the data in real time for patches that are extremely close to the camera, and or rather we just need to update the data that is on the GPU if the camera is close enough to the terrain patch. So if we have an entity walking around on snow very far away from the camera, we just update the data on the CPU real quick, just changing some float values based on position change. We do this on a separate thread. It won't halt the main thread or anything. But then if the camera moves closer to that patch, that's when we need to send the data to the GPU as well. And since we have changed the data on the CPU, all the old changes will go to the GPU as well, but then we will also start updating it in real time to the GPU, and that's when we're gonna have to optimize the transfer of data. So not to use texture 2Ds and definitely not apply, but instead rely on something like this. But this is where my knowledge starts becoming fuzzy. I don't know what the best way for this is. Yet. You can't guarantee. I guess it depends on hardware, right? Yeah, this is probably what we want to do. Interesting times ahead. So I guess it's pretty simple, but I always trust bgolus. So if we take the best options to modifying a texture in the CPU console, you can use structured buffer bool array to send the data to the GPU and apply it using Blit and a custom shader. But if we do it like this, like how much quicker is... It's definitely quicker than texture 2D apply, I would think. We could probably go as, okay, 32 bits. I think I'm pretty okay with representing... I don't think I need higher values then is supported by byte, so 0 and to 255. So I think we could store up to 4 values in each of these, much like we did with color, but we don't work with all of these abstraction, not on the CPU nor on the GPU. Instead of working with float force or color on the CPU, color 32 or whatnot, we just work with real values and pack them nicely like this. But But what we can see here is, if we do it like this, we also need to keep, if we pack data into its own struct like this, we're going to be careful so that we only pack, there's really no need, like, it would be bad of us to pack one data type that changes often together with another data type that changes not often, because like when we would change one of these, we're gonna have to send down the whole thing again. I'm a little bit worried about this fact though, because that means that there's really no gain from having a struct that just has 1 byte. One sec though. Okay. Mm. Harry, were you having performance issues with text apply stuff, or are you trying to replace that, or are you looking to do something else? Right now, we only update terrain textures when we do terraforming. So if we change the height, or if we add water and stuff like that, for those cases, we didn't really have performance issues, I would say. So for that purpose, it worked. Although it was, like, if we do some analysis on it, you can see that it's quite heavy for what it actually does. And if we're planning to, which I want to do, update a texture every frame, it's definitely going to be noticeable. And that's why I'm looking for ways around it, pretty much. We can see here we had, did I close that one? I don't know how much truth this holds, but if we take a look at it's also this fact, like if we rely on this one, it adds some constraints of how we can use and work with the data as well. Like if we would store, like if we keep the data like this and we do it like this, then we can alter this one whenever we want from whatever thread we want. As soon as we start including texture 2D stuff, it becomes a little bit harder. But as I said previously, like I'm still expanding my knowledge about this, so don't take anything I say for facts. But what I'm trying to get at is, if we want to rely on texture 2D, that means that if we want to rely on apply, that means that we need to have the data as a texture on the CPU as well. If we go with this solution instead, we can just represent the data on the CPU as arrays of bytes or arrays of structs or whatever. But on the GPU, we don't need to do textures at all here. I reckon you could make it so that you had a list of texture changes per frame. Then at the end of the update loop, upload the changes to the GPU and have a compute shader to edit the texture using the data. That way you upload less data and it should be very quick. No, listen here. Like, I'm open for anything. I think this is going to be quite interesting to implement, and we could very likely end up with something similar as that. That's pretty much, it's close to what we're doing now. But I would really like to get away from this and this. Okay, because when I think about it, like currently we work with textures on the CPU and the GPU, but there's really no need to, like, this is not textures in the traditional sense. This is just a package for data. So we don't really need to work around the abstraction and extra stuff that the texture 2D or texture class has. Textures will only need to be the GPU representation. Yeah, exactly. So if we move away from texture 2D, we skip apply, so we're gonna have to send the data in some other way. That's what I want to do. And I think that's the best way. So on the CPU side of things, it's going to be represented by arrays, 2D arrays, of course. It's basically going to be the same representation as a texture, but without the extra fluff. And then we can send it like this, because I trust this. But then again, yeah, I'm gonna have to research this a bit more. If we take a look at set data, it would be extremely nice if we could have an offset here, or we could have a length. So if we just update a portion of the texture, or I'm still saying texture, but if we just update a portion of the data, we just send that tiny little updated portion. But might be hoping for too much here. Yeah, I think I'm okay with this. And I love this RV. Although okay, But so pretty much on the CPU, let's say we have a scenario where we have a terrain patch 128 times 128. We have 5 objects, dynamic objects moving around. In each update for each of those objects, we take the world position. Do we want world position? We take its position, transform it to the data, and update the compute buffer on the CPU. So we do that for every dynamic object in the scene in the update method. And then at the end of a frame, we take each buffer and send it to the GPU. How costly would this be? Harry, it's not that costly, at least uploading of a small amount of data like that. Okay, thank you, appreciate it. So if we think, I'm just trying to imagine the end, how it will look in the end. We don't need a new. So for instance, like what I'm wondering if I would get, oops, what the hell is happening? Would I get away with, we have a very, very, very big terrain. Let's say that we have something like this. Okay, it's not very big, but yeah. Our base terrain consists of 4 times 4 patches, so 16 patches. Each patch is, I don't know, the higher the better, but let's limit ourselves to 256 times 256, which means that we maybe have, so for each patch we have one height of this size. Let's just call it age. We have one that has those things doesn't really matter that much because they don't change that often. And I'm always open to adding more. But let's say that we have terrain information which is 4 bytes, and that includes height, foliage, and something else. So that's one 256 times 256 times 4 texture, or array struct. Then we have water information, which is going to have 4 as well. Whatever. And then I have my dynamic texture or activity texture A. We're going to have, we want to try to keep all of these as, there's no difference in sending down. I don't think, we need to look into this as well, or I need to. There's no difference sending an array of bytes compared to an array of, or it's no difference sending an array of 8-bit structs and an array of 32-bit structs on most hardwares, I guess. Right. So if we have our activity texture, we have 4 values we can put here as well. Terrain data only updates when we terraform stuff. I'm okay with that. It doesn't happen that often. So for instance, we only send data to the GPU when the player is actively digging, adding dirt, adding grass, cutting grass, whatever. So that's not very often. Water only gets changed when we add or remove water, or when we dig or add dirt. So these two are pretty static changes, i.e. we're not going to send this data to the GPU that often. We're mostly going to work with it on the CPU. But this one is the culprit, because this one, best case scenario, I would like to update this one once every frame, right? So in this case, we're sending 16 times 256 times 256 floats every frame to the CPU. But then of course we can do some optimizations. So if the camera is located here, we only send this, and this terrain patch data to the GPU each frame. We could even make it so that so we base it on position, but then we can also base it on view angle. So in this case, we only send this one, this one, this one, and this one to the GPU each frame. And using this, we might get away with it. And you only need to send the changes to. Exactly, so we can go even, we can sort it by even more. That's a good point. So for instance, this one might not change, and this one might not change. So we just send this one and this one, and then we have gone down from sending 16 times 256. I hate writing numbers with this. 2 times 256. And sending this is definitely more efficient than adding a second camera. That also comes with, yeah. And as for your second question, yeah, this is interesting. Do you need to upload the entire texture? Best case scenario, we would only need, so if we have an object moving within this area, it would be extremely cool if we only needed to send this one as well. Unfortunately, by my quick glance over compute buffers, it doesn't seem to be, I don't think we're able to do that. Not, oh, whoa. Okay, we can, I think. Or this would be amazing. This would be extremely cool. I'm a little bit, I wonder about this one. When you have written to the array call, okay, yes. So we might call, ooh, this is nice. So we can put, we do 3 begin right, and then after the third one we do end right. Harry O could do something like this: struct change byte x byte y vector for data, then have a list change you can append to that over a frame. Then at end of frame upload the list to the GPU and clear it for use next frame. Then run compute, iterate over the list and sets the x and y of the text to data. Fuck yeah, my man. I think we're approaching a pretty damn good solution here. Definitely. So, oh fuck, this would be beautiful. So then in this case as well, and we only have a change here. So in this case we might bring it down to, in the end we might just send down 16 floats of data. And wow, and this, I think this is going to be very fun to implement as well. Wow. Depending on how the system works, I would probably like to use it for terrain data as well. Currently we rely on a Blitz solution for terrain data, which means that we can change a big area real quick. But I mean, wow. So this terrain patch, for instance, it keeps track of all of the changes that happens when a camera is not looking here, right? But the changes is just, it keeps track of the area that we change. We could use some cool mathematics to optimize that as well, because you could see, but then again also, yeah, we have to keep, like, when we store, Harry, I've got to go, sorry, please forgive me. Oh no, don't feel bad. Appreciate the input and discussion, and have a great rest of the day. Yeah, it's going to be interesting times ahead. So we're going to store the data in a row first, which means that if we change this pixel and this pixel, we're still going to have to include this buffer. So we can't optimize it too much. Like if we have a, let's see here, if we have data like this, we wouldn't be able to, yeah, and then we get changes on, let's see here, oh no, we get changes on these 3 points. We're still gonna need to send in these 3 and this one, or we could, no, we keep it on a row basis. Fuck yeah, we keep it on a row basis. So we send this as one change and this as one change. So then we do a for loop with begin writes for each changed entry. Maybe we were gonna do some testing, but I think like from going from not having any idea how to approach this or just vague ideas to actually having a action plan we can follow for hopefully a pretty good result. I'm feeling optimistic. Let's see here. Where do we have my nice rework and extend terrain data, rework terrain data, and underlying terrain and underlying systems. It's very vague, but whatever. The idea is to move away from texture use and instead move to custom struct arrays together with compute buffer. Compute buffer. Let's see here. And let's just put this to text real quick. Each terrain patch will have a set of data stored in struct. When a change is done, the data will be sent to the GPU using compute buffer. I'm going to go with the unoptimized approach first. So we're going to go with compute buffer set data, and then we optimize more and more and more. So compute buffer dot set data. Optimization includes only changing the data when necessary. First, for instance, when the data changed is close enough to the camera, is within view frustum, has changed at all. Eventually, only the altered portions of the custom structs can be sent utilizing a consent by keeping a list of changes in terrain patch, something like this. Okay. The first step would probably be to rework terrain data in such a way that we utilize it instead of whatever we have now. We just rework terrain data, make it work with the system we have. Let's see here. How do I want to do this? Texture generator, probably want to rename this one eventually, but yeah, let's see. Okay. I'm still thinking about where do we have it? This one. Yes, we're probably gonna do... Yeah, we probably still want to keep this as this, but not really color 32 because that sucks. So... Oops. Okay, how we want to do this. I still want to be quite general here. I don't want to be too specific. Otherwise, we could do struct water data. Fuck, do I want to be this? Public struct water data byte amount byte. We could do fuck, we could go pretty crazy. Byte amount vector2 direction and stuff like that. We could do this, so be very specific. Terrain data includes a list of water data structs, and this looks way nicer in code. It does. So if we have water data dot amount, it's pretty straightforward. Instead of working with terrain data types. But also it's the communication. We're going to do a lot of calls that's very similar to this get value terrain data type height. We're going to have a lot of branching and stuff like that if we don't do it like this, I guess. Because how would you do it if you have a custom structure like this? So you have terrain data as well. So then we're going to have to, you could either do send in terrain data type and then do if else, or you have get terrain value, get water value. So would still probably fuck, I want to rename this one terrain data container as well. Or we obscure it like this. So now it's pretty much we replace color32 with terrain data struct. Let me just exit this one. Can we do also fuck, I don't know the terminology. Do we need to override it ourselves, or would it be better to Yeah, what's up, Robert Patterson? Yeah, sure. Feel free to share it. I also took a look at the VS Code styles. They looked pretty damn good, actually. Oh, come on. Thank you. You're not sure about that? I think they looked pretty good. Nice, nice, nice. Fuck, I'm even wanting to do something similar myself. How did you implement it? Yeah, if we want to do this in a quick, nice, general way, we're gonna have to be able to... I need to be able to... access these by indexers. Or we could do some byte shifting and stuff like that. Well, Bezier curves and generating mesh around it. Is it like does Unity has a package for Bezier curves? Or did you use a third party, or did you write your own? Let's see. Yo, what's up, Fabic? How are you doing? What are you up to today? We're doing some very interesting rework on the terrain data. I think we found a very good way to do it. I can summarize it real quick soon. Ropesson, it's Godot. Oh yeah, sorry. I wrote based on Freya Holmier's tutorial. Oh yeah, that's nice. So Fabic, we're working the terrain data. We're moving away from texture 2D containers, and we're moving on to compute buffers. So pretty much what we want to do is we want to keep it as custom structs on the CPU, which we define a custom struct and then we do a native array or just a array. We want to make it as thread safe as possible, and that's how we're going to keep it on the CPU. Then when we need to use it on the GPU, we're going to use initially compute buffer set data, but then we're going to optimize it by only updating the terrain patches that are close to the camera, only updating the terrain patches that can be seen from the camera, only updating the terrain patches that has any change, and only update the data in the area that has had change. And we need to do it like this because we have one data texture that is worst case scenario is going to be updated every damn frame. So yeah, moving away from thinking about the data as always needing to be stored in a texture related fashion, and relying on compute buffers. I think this is going to be sick. Eventually. But yeah, I don't want to. It's not indexers. Because eventually what I want to do is, let's go with native array. We want to do this, and then I would like to, for instance, do data index, or actually we would like to do it like this. We would like to do it like this, and then we do type dot, I don't know what we want to call it, macro index pixel index type dot micro index, something like this, I think. Because we're gonna have multiple native array, we're gonna have multiple or one sec. Yeah, so pretty much we're gonna have multiple arrays of this struct, and I want to easily differentiate between them. It's pretty easy by doing this, but would like to be able to access these or are we gonna have, could we do it as can we do something like this? It's important to me that we are able to access this by indexers. Not so sure that's possible if we have them named like this. Unless you do some branching here, but I want to avoid that. Mm-hmm. Like how, for instance, is it implemented in vector 3? X, Y, Z, but we can also do it's pretty much exactly what I want to do. I can't imagine it being solved by if else here, right? How screwed would I be if... And maybe we should just do it as an array in here. Let's see. Fabric, write your own vector 4-byte structure. Maybe. That's pretty much what we're doing. I just wonder exactly how it's written. Is this actually just a... Do we write it as byte data? Data is equal to new byte 4. We can do it like this here. And then we use indexer, so public this touch history. Something like this. Oh, what's up, Harukanan? Thank you. Let's take a look at this one. Ah, fuck, do they use it with the switch case? Wow. Huh. What the fuck? I just thought... there existed a better way. Okay. And yeah, morning, just got out of a dev meeting. Hope it was a productive one. Oops. Public byte. This. Now let's just do it like this. Index out of range exception, throw new. How to kind of know mostly shit I don't care about at all. The IP version 6 DHCP system was nice. But the rest was about moving phone systems. At least it was some nice little tidbit in there. Wait. I guess we could actually do vector 4 byte unity. Okay, we don't have it. Yeah, so we do it like this. Yeah, let's see if we can use this one as well. That would be very nice. Just which one is it? Is it? Fuck, can I utilize these as well? That would be very nice. Because I guess this is the one that actually makes this feasible. Yeah, maybe. So what do we need? First of all, I want to figure out or can I rely on these without doing too much of this? Fuck, all I want is a nice vector 4 byte, pretty much. Fuck it, let's do it like this right now. Possibly wait compiler flags. And let's do it like this. I'm lazy now. Fuck, do I really? We do it like this for now. I guess we have a very big we can do some optimizations here because this doesn't just feel right. And yo, what's up, Fabic over on YouTube? Thank you so much for the donation. It's really, really appreciated. And I hope you're enjoying watching me trying to implement a vector 4 byte. But I'm really believing in this solution. So yeah, thank you again. I appreciate it, man. Okay, and then I think I want to do it like this. Fabric, I enjoy everything. Nice to hear. I'm not entirely sure I like... this is how we're gonna have to do it, yeah. So, data, private native array, terrain data struct. So now we can do exactly this. Private int width, private int height, yes. So So we're going to do it like this. Private field render texture data as render texture. Yeah, it's mostly because of this blit here, but this is not how we're going to do it in the future. Fabian, I'm slowly buying shares in R.S Technologies. Yeah, the name is a placeholder name, okay? So the most important part here, oh, let's see, one sec. Yes, we need a set of compute buffers as well. Number of objects. So we're gonna have data, we're gonna have it like this, and then we're gonna have private compute buffer. But I'm wondering here what the pros of using native array in instead of just array would be. Thread able to manage a native code without marshalling costs. You can use them safely in jobs. That's why we want to do native array. I'm a little bit worried about using compute buffer with jobs. I don't think we will be doing it. But so let's do it like this. Compute buffer. So all of this will be one compute buffer. In fact, do I want to... Terrain data struct, do we want to have... I wonder if I want to clean it up, like if I want to do it like this. Maybe we should implement renaming this one to vector4 byte. Keep it in its own separate file. And inside of here, we create a terrain data pair, pretty much, that is maybe that's better. Maybe it is, maybe it is, maybe it is. Distribution range. But I don't want to call it vector4. And I actually want to keep it close to the terrain, I think. terrain data is such a good name for that. Terrain data container. We're gonna do a renaming. Yeah, let's do it like this. Terrain patch data. So it pretty much goes like this. Terrain contains a set of terrain patches. Terrain patches contains terrain patch data, and terrain patch data consists of terrain data. Is that too much of a rabbit hole? Maybe. How much did I screw up now? Probably not too much. Okay, let's see. Terrain patch data. Yeah, we're gonna change this one a lot. System collections, Unity engine. Terrain data. Let me do this. Can we do... terrain data. Okay. But what I also want to introduce is... fuck, I wonder if I want to do this. Terrain data. One sec. Terrain data, public class, terrain data package. And this is where we do pretty much what terrain data package is terrain data, a terrain data package with a corresponding compute buffer. So we always keep those together. So this is pretty much my answer to Texture 2D, I would say, but without the bells and whistles. Terrain data package, so here we do private int width, height, okay, height, we do private terrain data package is also the one that's going to keep track of changes, I think, eventually. Private int width height, private native array, terrain data, private command buffer, terrain data package, or terrain data buffer. Fuck yeah. Terrain data buffer. Data is equal to new native array terrain data width times height and allocator persistent. And then we do, fuck, actually, public int width height. Can we do public get private set? Yeah, then we can't do it like that. Something like that. I'm going to chill a little bit with those. Width times height, allocator persistent. And then I also want command buffer is equal to new command buffer. Where do we have it? Oh, yeah, that's good. We want this to be a compute buffer. There we go. Sorry about that. There we go. Compute buffer is equal to new compute buffer, and let's see. Count and stride. Size of one element in the buffer in bytes must be a multiple of 4. Okay, beautiful. We just have 4. Could go pretty damn crazy. What? Wow. Yeah, we're gonna do basic stuff first of all. So we're just gonna do multiples of, or we're just gonna do 4, right? So compute buffer count width times height and 4. But we can do it a little bit nicer, so we do public static int size. What the fuck, let's do it like this. I thought Terraform, no, not Terraform data, terrain data size. Eventually gonna have a lot of methods here as well. But okay, let's see what we have here now. Terrain patch data with height, we don't care about it here. And here we do native array terrain data buffer. What am I missing? Yo, what's up, Derek? Thank you so much for the donation. Appreciate it. Maybe this will help you with all the technical debt you're paying off. Lol, keep up the good work. Thank you, appreciate it. Yeah, you guys are definitely making this easier, it feels like. Also making it a little bit hard. I'm getting really touched by the kind words and the donation. I really, really appreciate it. Okay, yes. So yeah, we're hopefully this is the final solution and it works. It's very performant. And we don't need to change it after this. But let's see here. The type terrain data buffer must be a non-nullable value type in order to use it as a parameter. Ah, fuck. So it's the problem that we have this one as a class here. That sucks. I didn't know we had this constraint, honestly. Yo, welcome back, Harry-O. Why use native array? I want to get some of the bells and whistles from, like, I want to be able to, or let's see here. It's this one. I like that we get this for free. But it shouldn't be that much of a hassle to make it safe on our own. And I like this too much. So you're probably right that we could do this instead. But then we have to be careful. But yes, this is true, this is true. Look at this. This one never changes after instantiation. We don't change this one after instantiation. This one does though. Harry, I think even a native array has overhead if using it like an array just in C#. That is definitely or we do to do. Overhead and pros, cons compared to native array. So right now we just use native oh yeah. This one never changes after instantiation. This one does. I'm gonna keep this one around a little bit longer. Just a tiny bit longer. Yo, what's up, DevSpios? Enjoy the lunch and thank you for the raid. Appreciate it. Yes, we instantiate this one at game startup. Then we leave it as is. These values are going to change from almost never to very often. And we're going to have separate threads going into this and changing it. But yeah, definitely need to research this so I can choose native array or array with good confidence. Okay, so let's see. Terrain data buffer. Render texture. We don't need render texture anymore. I'm pretty certain. Fabric going into lurk mode, have to do some real life side quests. Good luck with those. And appreciate the lurk. And thank you. New data blit material. Yeah, we used a blit here. Probably not going to do it this time around. Instantiate data. Let's see, how do we want to do this? Yes, okay. So instead of this, what we want to do here is terrain data buffers is equal to new terrain data buffers buffer array terrain data type methods last texture index. This enum is pretty important, and I think I want to keep it around like this. Yami, thank you for the follow, appreciate it. We pretty much define exactly what type of terrain data we are interested in here. Height, foliage, unused, water previous. These are temporary and might be subject to change, but we're gonna keep them like they are right now. Harry-O, you'll need to run data dispose as well at some point if you choose native array, especially with allocator persistence. It's effectively malloc, but you'll need to free. Definitely true. The way I think about this is terrain data buffers. We're going to instantiate these at game startup, and we're going to have them around forever, pretty much. So it would be on game close down then, I suppose. Yeah, but that's definitely something to keep in mind. So terrain data buffers, new terrain data buffer, and here it depends on how let's keep this one here, data type. Here it depends on how many types we have. We can package, one type is for 8 bits, so 1 byte. And we have, so what we do here is we return the last, which is timestamp currently. This one has a value of 7, and then we do texture index, channel index. So texture index divided by 4, which means that we get 0, 0, 0, 0, 1, 1, 1, 1. But now we're not working with texture and channel index, so I want to rename these to... Previously I talked about macro, index macro and index micro. I don't know if that's much clearer. So it's probably going to be buffer index and data index, I guess. Oops. Because then it's going to look like this: terrain data buffer, terrain data type methods dot last dot terrain, what is it, buffer index. So we take the last terrain data type we want to represent, and then we take the buffer index of that one, and then we know how many, but then we need to add 1 as well. So that is how many terrain data buffers we need. Very similar to Texture 2D, but we work with terrain data buffers instead. So this one is done. This one is also done because we have terrain data buffer contains a compute buffer, so we don't need to represent this one out here. If do we need the index here? I don't think we do this time around, so we can do a fuck, we do. Never mind. Why am I getting... Yeah. And then we do terrain data buffers I is equal to new terrain data buffer with height, and that's about it. We don't care about wrap mode, we don't care about filter mode. We pretty much get, yeah, no, we don't need this. That would suck if we needed this. So yes, all we do is this now instead. Let's see, what do we have? Here we just instantiate data. This is a little bit of a hack I've done, which sucks. Terrain patch data, new blit material. So this is basically, this is our solution to reading terrain data from file-ish, our file being a texture 2D. Right now, I'm thinking about, and what do we have here? UV generation offset. Yes, and here we have, so we have creating an empty terrain patch data, creating a terrain dash data from by loading, and creating a terrain patch data from, or generating it. As for this one, we're gonna do this for now. But as for this one, I think we can work with this one, maybe. Color generate, texture generator. Fuck. Also extremely tied to texture 2D right now, unfortunately. Generate texture. I wonder if we can do, for now, maybe we can just do vector 2 float good. Naming these texture might have been a bad choice. I might just rename these. Do we actually use these anymore? Yeah, we do. But why? Why don't we just use this one with a Perlin noise texture channel value generation? That's weird. It might just be that I haven't moved I have some code that's still lying around, because it should be enough with this one. Definitely. Generators, texture generator setup. iData value generator constant. Okay. This one always with the texture generator. In fact, then I want to do I want to add a terrain data generator here, but I want to keep it together with the other terrain data. We can do it like this. Terrain data buffer. Int height, and then we do idata value generator generators. What is it? Super? No. What the hell? But we want to do it like this, or am I missing something? Public terrain data buffer. There we go. It's been a while. And then we want to do for I is less than min math f dot min data dot length or generators dot length. And then we basically want to do this, but we want to do it by data instead. I wonder if I just want to keep it like this, actually. If generators dot length is not equal to terrain data size, or just data.length return. But we can also let's do a debug log here as well. generator or data let's just keep it like that for now. Because we can optimize this step quite a lot if we just have the correct size, or optimize and optimize. We can write it a bit cleaner if we have it much cleaner. So let's just copy this here. Yeah, we skip this one. Let's see, because what I'm thinking of doing here is we just do... Ooh, did we package this height first? I don't think it matters that much. So let's go... we will notice it. Height. UV with height. And then we do... Pixels is wrong, but we do... Let's see here. Data. I guess this is where we decide if we want width first or height first. I think I want width first. But no, we don't decide it. Well, we decided. We don't really care. X. We decided. We're pretty much just working with an array down on in the shader as well. A structured buffer, I suppose. So, how do I want to do this? X. I think I want index 0 and index 1 should be neighbors, or we should be moving in with direction, I think. Right. And then we do data I times height plus width is equal to new terrain data and here we do generators 0 generate value uv, and then we basically want this 4 times. But we're working with float here. Ooh. Generate value. Might get some weird stuff from here. Should be okay. And here we do public byte generate value float u float v return byte generate value uv times 255. Generate value public byte generate byte value 255 should be okay. So here we do byte value. And then we skip this one. Maybe not this. So something like that. Yo, what's up, Cynic? Well, 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 indeed. Am I missing? Nah. Yeah, I'm good, I'm good. I'm very optimistic. I think we're doing a little bit of a rework on the behind the scenes systems. And I'm optimistic about the solution we eventually arrived at. How about you? So this constructor in this case would just be, I'm also thinking about simplifying this one to data value generators. Like this, and then we don't call texture generator here. We do this. Instantiate data. Yeah, we do this. Now it's almost like... I think we can do it like this. Instantiate data. Well, let's do it like this then. So I'm all right. Nice to hear. Just noticed I've received the wrong pay for half a year now, so this month I get a thonker. Oh, nice. Nice. If thonker is meant to be good, that is. I used to work in a salary office, and I've seen it go both ways, definitely. Some people got the very good end of the stick. Some people, I didn't want to be them. It didn't happen too often though, so that's good. Yeah, I think we're gonna do it like this. Private void instantiate empty data. Does it really matter? Nah, honestly, I don't care. I don't care that much about... Yeah, we want to do this either way, so let's just do public. We don't do this as a constructor, we do it as public void generate. Yeah, generate data. And then we do... What is it called? Data value generator. Generators. We'll do it like this. If generators length, data length, this, and then we do this. Okay, so in this one right here, we simplify it to, we instantiate the data. Let's make it a little bit nicer. I'm more of a fan of writing it like this, instantiate data with height. And then, true. Let's see, what did we, yeah, we split it up previously. Okay, that's good to know. This is true, this is true, this is true. So this one consists of a list of this one. Each one of these take 4 of these. We could either go use the same generators for each set here. I think we can do it like this. What I would like to do is I would like to be able to send in a varying amount of generators here. So but if we don't have enough, we're just gonna add an empty generator. So it's pretty much gonna be a constant data value generator with a value of 0. So we can do but then we have to package them up into units of 4. Let me think about this one, because unfortunately I'm gonna have to put an end to this right now. I will only be able to do 3-hour streams this week. Life, you know. But let's just summarize it real quick. We're in the process of rewriting the underlying system for terrain data. We're moving away from texture 2D and we're moving towards compute buffers instead. We have a nice little framework for when and where we should update these textures, which means that we will probably be able to support real-time updates of textures, and more specifically an activity texture, which we can use for amazing stuff. I'm Cynic, always me joining in the end. Yeah, I know. Hopefully in the future I will be able to do longer streams, but this week 3 hours, unfortunately. But okay, I think it has been a great stream, great research. We did some nice progress. Thank you so much for watching, everybody. I really appreciate it. Fabik and Eric, thank you for the donations. Very much appreciated. And have a great rest of the day, and hopefully I will see you tomorrow. Peace.